Hi, this is LogIn T.Baum, and here you can see our technical demonstration video. Our four chosen features are locomotion, robot communication, personal tricks, and human interaction. The first and most important feature for us is locomotion. We chose this feature as we wanted our foxes to drive around the stage to be able to represent real foxes better. We based our performance on this feature, so you will be able to observe it all the time. This feature works with 4 motors, one in each leg of a fox. All of these motors are connected to an H-bridge in the fox, with the right and left motors sharing channels as front and rear legs need to do something different. The H-bridge is connected to an Arduino Pro Micro, which controls the ports of the H-bridge, with 2 pins changing the energy flow's direction for each side, and the third one controlling the speed of the motors.
Then, we chose to include robot communication as we wanted 2 foxes to communicate wirelessly. You can see this if you look at the 2 small foxes on stage, as they're communicating all the time, one being told where to go. This works using a Calliope Mini V3 in each of the communicating foxes, with these 2 being connected to the foxes' Arduino boards. We did this so our actual code can still run on the Arduino board and the Calliope stays completely unrelated to it. It'll read which pins get power from the Arduino board and send BLE signals based on that. This way, the Calliope in the master fox can't interfere with the actual code. For our slave fox, we couldn't do this, but it works in a similar way. The Arduino board reading which pins get power from the Calliope instead of being the other way around.
Our third feature is personal tricks, which works with having given each fox different equipment. One can turn its neck using a servo, whilst another can sit down using a servo as well. 2 of our foxes can communicate via Bluetooth, and one can even drive relying completely on wireless communication. This feature was developed with a simple idea of wanting to include difference, which makes everything a lot more interesting.
Our last feature became human interaction, cause we thought it could be interesting. This feature can be observed multiple times during the performance. Once in the beginning, when the human whistles with a high-frequency whistle for our fox to recognize, which actually starts the whole performance. Another time, when the human throws food toward a fox, which is supposed to detect. Our third human interaction is meant to happen toward the end, when the food gets picked by a fox and brought back to the human.
We assigned each other roles during the development of the project. One role is the software engineer who is responsible for creating all the software and trying out whether it's working with the hardware. Another role is the mechanical engineer whose responsibility was to create and build all the foxes as well as the stage building and costume design. The third role is the communication engineer who focused on doing just the wireless communication of the robots as we wanted this to work and it was quite difficult. We also have a documentation manager who focused on the technical documentation part of the score sheet. They overlooked the poster and created most of its design, as well as filming most things and creating a video. The last role we have is the electronics technician, who focused on everything regarding the hardware. They soldered most of the cables due to each fox having around 20 and interconnected them within the fox as well, so the hardware could actually work.
Although we had those rules, all of us supported each other and created things outside their rules during the project creation. A few examples for this are the electronic technician filming for the documentation manager, the software engineer helping the electronic technician with parts of the soldering, or the communication engineer helped the mechanical engineer to build one of the forks.
During the creation of our project, there were a lot of difficulties we had to overcome, starting with this being everyone's first experience with anything regarding robotics or programming. The first problems appeared when we tried to create just a torso with legs, as we had to find a way to connect these 2 pieces, both being made out of old pipes, with each other. Our original plan was to drill a one big hole for each leg, but we didn't have the right material for that, so we had to find another way, ending up with drilling smaller holes and putting wires through these. Another problem we encountered was that the heads were rigging in the beginning, which we solved with using thicker wire, also making it possible to place the sensors and ears in the head, as the thin wires couldn't hold all of that weight.
There were a lot of problems with the software as well, the biggest one being when we realized the libraries for a microphone sensor and the servos weren't compatible, so we had to end up dividing our code and putting it on multiple boards within the Fox. Another problem was to find a way to do the Bluetooth communication, as this seemed really difficult using Arduino. We chose to use OpenRoberta instead, which made it possible to create a working communication within only a few weeks.